2018. It's good to... Hello. Oh, how you going? How you going? This might take a while. We've got a new MelbJVM. I didn't prepare too many slides, so look at this cool trick. Normally we do the news and stuff. And look at, do you have a, yes, do you have a, so the news is going to be off this thing, but before I start that, we just want to, get some formalities out of the way. So let's have a look. All right, first thing, big round of applause for our sponsors, Aconex, putting on the beer and the food. I would like to introduce you all to Owen. Owen's an engineering manager here at Aconex and just has a few words to say to you. Welcome, Owen.
Thanks, Ron. Hi, everyone. I'm Owen. I'm an engineering manager here. In the doorman. Yeah, in the doorman. A little bit about Aconex. We make software for the construction industry, a big software as a service platform. And we were recently acquired by Oracle, if you follow the news. Yeah, Oracle 60. Yeah. We are hiring. We have 11 roles, or more than 11 roles open, from junior to senior engineers. We're also looking for a bit of UI expertise for our 3 core product teams here in Melbourne. So if you're interested, check out careers.aconex.com and Connor Light and C Light at aconex.com is our main talent recruitment person. So if you're interested, please get in touch.
Yeah. Thanks, Owen. All right, so let me talk about, let's see, whoops, that's a preview for tomorrow, for 2 seconds away. All right, a few meetup-y things. Our next meetup is, Meetup have changed their website. Our next meetup will be on Wednesday, March the 7th. And as of yet, we don't have any topics. So we are looking for speakers. So if you've done something fun in the JVM world, please come and contact us through Meetup or through whatever social media that you like, because we'll look for anything, be it frameworks that you've played with, or whether you've done it at work or you've done it at home. This Meetup doesn't happen if you don't show up, and we don't get involved. So please keep it in mind. And if you don't hear an announcement, then there's no Meetup happening. So get on it. Let's have a look. Does this work? Yes, keyboard shortcuts. We've got a Slack channel, so if you go to slack.melbjvm.com, you'll get taken to this sign-up page, and then you can join without anyone needing to invite you. We just post news on there. People ask programming questions on there. It's a good little community we've got. So get involved. We're going to do the raffle. If I forget, as I sometimes do, please remind me at the end. We'll go through some news. All right. So let's see. All right. So Oracle needs some information. I'm just curious as well. The security manager. Does anyone actually use the class security manager in their Java coding at any stage? A long time ago, was it with applets and no? Yeah. From what you usually might use a security manager, did you, Nazrin? No, sorry, just shaking your head back. The general thing is that I want to prevent access to certain classes. At runtime, I know that say when Google had their compute engine thing, the Google App Engine, and they would use the security manager to stop your own web apps from hitting, like doing system.exit and things like that. So it's traditionally been used in web apps, applets, things like that. Oracle kind of just want to get a feel for if people are using it. Jump to the SurveyMonkey link, and I think it's a 2-second survey about it. They do this from time to time with all different kinds of Java features. So it's there. If you want a good source of news and a good intro to reactive programming, Java magazine came out just recently. Thanks to Dave for the heads up about that. It's got reactive streams. It's a good looking picture. This is where you're at right now, just in case you need a reminder. Oh yeah, this was kind of interesting. So there's a new project proposal, basically adding the V8 JavaScript engine directly into the Java distribution, so that you can, instead of like using Nashorn or Rhino, you could actually use V8 directly. So there's a project proposal in there. It will also have some things like how you got with Nashorn, that you can call back to Java classes and do interop between Java and JavaScript. So that might be super interesting. It would also be quite, I presume, a quite cheap way to get the latest ES 2018 enhancements, you know, into Java, I guess. So that's a good thing. Juke Scripts came out with their own little framework. So Dwayneil, where are you? Yeah, Dwayneil did a talk on Juke Scripts many moons ago. It may even be on our YouTube channel. And they just had another MVVM framework, because, you know, there's not enough of those. So yeah, you can go and check out that thing. I like this thing about they're using Kotlin as well, and there's a few cool Kotlin React JVM libraries. I don't know if anyone's had a chance to look at those, but it sounds kind of cool that you can build React apps using Kotlin, and then yeah, build them on the back end and stuff like that. So who knows, might be worth checking out. Let's see. This one is kind of contentious. It looks very simple by this description. But basically, Oracle, now that we've got this light speed release flow, so basically every 6 months, every March and every October, we're releasing a new version of Java. Normally, in the old days, Oracle would release Java, and then they'd continue supporting it with patches and whatever else for a certain amount of time. Maybe a year or so after the next version of Java came out. Basically, because this cadence now is so quick, as soon as the next version of Java comes out, they're not going to do free support anymore. So free support is, I guess, bug fixes that people have publicly added, put on and on their Jira or whatever that is that they're using for bug tracking. And then you can use the paid support. So whether this is a kind of a ruse to get people to pay for corporate support, or if it's just simply that they've got to manage it somehow, and they're throwing this out and seeing how the community reacts to it. Yeah, you'll basically get free support. Generally what happens, like even going back to JRE 7 and JRE 6, is that usually someone from the community takes over the OpenJDK project. You basically, Java's open source. You can go to the open source, openjdk.java.net. People still maintain the older versions and do patches and stuff like that. So there's a little bit of contention around then, when that handover period occurs and when it can start and all that kind of thing. So I think that stuff will get worked out over time. So that bridges the gap that's closer. But for what it's worth, as of JDK 10, what will happen is that they're basically going to have feature parity. There won't be any known differences between the Oracle JRE and the OpenJDK JRE. So it's not really going to matter anyway. Like if you're staying up to date, it's not going to be a problem. But even like the publicness of the JDK for bug fixes will still be available. So even if Oracle choose not to do any more free support patches, then at least it's still the community's going to be around to do those. So that's what's going on there. Heinz Kiblitz. So if you came to our meetup at Message Media, where Heinz did the remote presentation through the VJug. He's got some really good Java courses. I've done a couple of his like what was it? A good one on Java and I/O and stuff like that. So he's got a sampler thing. Sorry. Transmogrifier. Yeah, he didn't talk about that in the thing, but I did. But yeah, it's pretty cool. Yeah. We are recording, so if we turn the lights off, then people watching on the recording will kind of not see me or Annie. Hey, all right. How about can you still see me? Do I look like a? Oh yeah, I'm talking to the internet. Hello, internet. Yeah. Sorry, just a black shadow. All right. Sorry, Desmond. The internet wins, and the history. I will try and zoom in. Oh, thank you. Yeah, you can like your spotlight, and you can excellent. Cool. I can just read it out to you. You can believe what I'm telling you. Just a couple more. JDK 11. So JDK 10. You've got this local variable syntax, so I guess a bit more like Scala. Let me zoom in so you know what I'm talking about over here. So you've got this var keyword, and anywhere that's locally scoped, I can, instead of actually having to declare the type of a variable, I can use var and let type inference do that for me. Now what we've got, and so basically that was for Java 10. What wasn't there this on a lambda as parameters. So basically the proposal is to add that for JDK 11. Yeah, when it comes in 12 months' time, I guess. Right. What else? Yeah, I guess October or so. Yeah. It's kind of weird not hearing anything about, like, we're February and there's now a Java and we haven't heard anything or much. Like, there's posts and stuff to the JDK list, but it's like, oh, okay, it's coming. Who's on Java 9, by the way? Yeah, why would you? Like, whose apps still work on JDK 9? Yeah, like usually it's like something like using a drop wizard or a Spring that hasn't caught up compatibility wise, and so yeah, who's using legacy code? Everyone. Yeah. Actually, I didn't retweet it, but there was this great pie chart that someone did as a joke. It was like people on who's on JDK 7, who's on JDK 8, who's on JDK 8 but in yellow. It was just a separate coloured, the same pie chart, but a different segment. Yeah. But yeah, no one's on Java 9 is the joke. Yeah, if you use VS Code, anybody using this for front end stuff? Just 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, cool. So yeah, there's Spring support. So they built it in. It does Spring stuff like you'd expect. You can run Spring Boot apps, and you can click through and find things in your Spring Boot apps. And I think there's probably some more intelligent stuff about bringing in certain jars and modules in Spring Boot. So check that out. Oh, this one, I forgot about this guy. There's basically who uses another language other than Java that supports multi-line strings, and who's ever wondered why the hell Java never implemented this a long time ago. So this chap is about actually let's go and explore it properly. Guess what the proposal is for multi-line? Not triples. Almost. Traditional. Oh, it's here somewhere. Guess which language has been copied? Yeah, well, yeah, and close in the ES, and ES is 6 as well, yeah. So that's in there. Although someone made a offhand comment on Twitter about, oh yeah, it looks very like in JavaScript, and Brian Getz, the language engineer, said, oh, you know what? That's not. It may look like that, but it's not. It's for other reasons that aren't as clear. That this is why it was backticks. But yeah. Who uses a backtick? So it's an easy one to pick. There's now one less thing you can use, but that's there. This is not really related, but Joshua Block, the book Effective Java, he's done a 3rd edition. I actually haven't read it yet. Has anyone else seen it or read it? You have it with you? Yeah. Is it good? Yeah. Is it thicker? Is it thicker than the old one? Oh, yeah. Yeah, excellent. Yeah, very good. I'd like to hear more too. All right, yeah, Corba's finally going to be gone from Java 11, not that anyone would miss it, and yeah. And I think that's about it. So with that, just, yeah, remind me to draw the raffle if I forget. But otherwise, we can swap over. Annie, you probably recognise Annie from doing the news, and he works as an Android developer at National Australia Bank. He's still there at a large financial services organisation. We'll edit the video, don't worry. Yeah. Yeah. Excellent, yeah. We'll edit that bit out too. Please welcome Annie.
Make sure that doesn't fall. I'm being advised by Tim I should move this a little bit closer so it's a bit better for recording.
You're going to lose your paper very soon.
It'll be fine. So, we go back there? If I get a little bit quiet, just give me a bit of a shout because I have a bit of a volume problem. But I think Con did a quick introduction for me, so that kind of defeats this slide. I've been using Java since about 2009, since I started at uni. But I'm probably going to start this off with a little bit of a story. So with Android development, there's a bunch of complications with framework, since Google only just recently sort of mandated some of the framework things. So about a year ago, I was actually exploring how to sort of solve a problem. And one of the things that I wanted to do as part of it was sort of boilerplate out code, make it so I could generate it, and also make sure that I don't have to keep regenerating it by myself for something like a template. So one of the things that we tend to use a lot in Android is annotation processes. So this sort of started my story, how I was sort of exploring the annotation process world. And I've actually written 3 libraries, which I'll not really talk about too much, but I'll talk about one of them. And yeah, just sort of work on publishing them and productionizing them, and they're actually on Maven Central soon. So this should be a audience culling poll. Probably everyone's used Java here. I hope this is a Java meetup. Duh.
Pizza meetup.
But okay, so because you all use Java, you probably use annotations. So everyone's probably used the override annotations on a method, just a little bit of syntactic sugar, that sort of thing. So now, probably put your hands up, I guess. But who's written their own annotation? Yeah, okay, that's cool. And sort of on how you sort of read that annotation, who's actually done runtime reflection and sort of done that sort of stuff? And now, who's actually written a compile time annotation processor? One person, great. If everyone left their hands up, I would have just gone, yep, talk's done. So this is sort of what it's about. So just a bit of contents. I'm just going to give everyone a bit of an introduction to annotation processing, how the compilation works, do a bit of a preamble on annotation processing. I'm going to focus on a library called JavaPoet, which I'll talk about. We've actually got some code, which is pretty awesome. And I'm going to share some useful snippets and sort of some learnings, which, you know, not reading the doco, yeah, you end up with a lot of learnings from that. So this talk is about 30 minutes. It's a fair bit technical, hopefully, so brace yourself. So probably everyone sort of knows what an annotation is. It's like a little bit of syntactic sugar. Use it at compile time or runtime to sort of put some extra bit of information. It's a bit of metadata. But annotation processing is actually a compile time step that's been introduced as part of the JVM. It allows you to do a lot of things. So you can actually do a bunch of code inspection, generation stuff. But you can actually do a lot more than just code. So you can actually generate Java doc, for example, if you also if you wanted to, you can generate documentation. You can do a lot of generation-based tasks. It's actually been around since Java 5, but not really usable until Java 6, when they actually properly fleshed out the API as part of JSS 269. So if you're still using Java 5, shame on you. So what happens during the sort of compilation phase is the Java compiler actually picks up a special metadata file, which I'll talk about a bit later. And it goes through this sort of compilation loop. So if anyone's wants to grab the slides later on, I'll put it up. But there's a link in the speaker notes, which actually talks about a bit more about the sort of compilation process. But there's these three phases. You've got a sort of parsing and entering phase, annotation processing phase, which actually loops around and repeats and repeats and repeats itself until there's no more code generated. And then you have annotation processing, and then you have an analyze and generate phase where it actually converts your Java code into class files. After compilation, your files are actually fully inspectable through annotation processing. So that's really cool. You can actually see what's going on and try and reverse engineer it if you need to. Using annotation processes, if you're a Gradle user, there's actually a bunch of sort of directives as part of Gradle. So there's apt. If you're on Android, there's the annotation processor directive. And if you're using Kotlin, there's kapt. For Maven, there's like a sort of similar one as part of the XML file for your Maven file. But I think I mentioned there was a special marker file. So if you're just using plain old Java compiler, you can use that file, and it indicates that there's a annotation processor in your actual asset. If anyone's using I don't really know the answer to this because I use Gradle. So if anyone's actually been around to some of my previous presentations, I did one on Dagger, which is actually a compile time dependency injection framework. And these will actually kind of look familiar. So sort of the pros and cons of annotation processing. A lot of the pros is that it's a sort of don't repeat yourself kind of a thing. You don't have to keep rewriting things. You just annotate more. It's a lot more powerful. Arguably, it's a lot less maintenance. So again, you don't have to keep regenerating your templates every single time you compile manually. It just does it for you. Any failures you can actually do and deal with at compile time. So you're not just running code, hoping things work. You have like a really long startup time as part of a Spring application or something like that. You don't need reflection. It all happens at compile time. You have the inspectable and analyzable output, which is very handy for auditability. It's minifier friendly, so if you use ProGuard, Guardit for Android, which is one of the sort of minifying frameworks, you sort of lose complete context in the code because it sort of compresses your code and mangles it and minifies it. And it's actually testable, but I'm just sort of going to skip past that topic because who tests their code anyway? Some of the cons, again, with the Dagger one, it's a bit of a learning curve, so it takes a little bit of time to sort of get familiar with the annotation processing framework. It took me about a year to sort of, and 3 libraries to sort of work it out and iterate on it. Generics are actually pretty tricky to deal with, but there's actually ways around this. There's some framework gotchas, but they're not actually too much of a con if you figure out how to deal with them. And it's a little bit annoying to debug. That's really it in my perspective. Oh, and if anyone has questions or comments or anything, feel free to shout it out, raise a hand. Yeah. So I actually did a sort of existing tools and frameworks poll last time. I presented this at work first, and everyone, because they were an Android developer, got it in the exact same order. But that's because it was an Android sort of oriented talk, and yeah, I don't have that same expectation. But does anyone know some annotation processing libraries that they've probably used out there? Just say it. Close enough. Damn it. Yeah. So there's actually Google Auto, which is quite handy also. There is Lombok, which is actually really cool because it's an annotation processor, but it manipulates files and your actual Java class files.
It doesn't work in Java 9.
Yeah, that's a fun one. It does now? Okay, cool. So it actually, based on the compiler you're using, it sort of detects which compiler you're using, if it's either the Eclipse compiler or the Java standard compiler, and it actually generates and manipulates your source files. So if you have like auto-generated files or anything, or properties and getters and setters, it actually generates it for you. Dagger, obviously. Butter knife, this is probably more Android-oriented ones, but I'm going to skim over those. Android annotations, Android data binding, architecture components, so on and so forth. And again, if anyone's looking through the presentation notes later on, I've actually got a link to how Project Lombok actually works, because I think it's actually pretty cool. So these are my libraries. I consider this sort of my shameless plug. I'm probably going to focus more on Stasis, because that's where I did all my examples from. But the point is it does a bit of code inspection. It's actually able to do a bit of pre-processing, and then it spits out class files, which can actually be used as part of an Android application, but it's not limited to Android. Okay, so a bit of a preamble to annotation processing. So these are sort of the fundamental types when you sort of start digging into an annotation processor framework. This is actually part of the JavaX sort of package, and what the JDK and JVM developers actually designed was actually a bunch of different classes to represent your Java class files and all the sort of constructs within them. So there's a sort of breakdown of them. Probably the most commonly used ones you'll end up using are actually up the top. So element sort of represents the sort of parts of your file, their Java constructs. In types, so you can have declared types, interface types, that sort of thing. Got type elements, which are a bit more specific, and then there's actually a neat little one called a type mirror, which we'll probably see a bit later on. When I started off annotation processing, I actually didn't look too much into the utilities classes, but these are sort of analogous to each other. So there's a sort of types class, and a elements class, and these are sort of utility classes that allow you to sort of convert between each one, and you'll end up doing that a fair bit actually. And another useful one is actually the element filter, which allows you to sort of go, okay, I've got a class, I want to find every single method in it, and it's a nice little convenient utility part of it. Yeah. Yeah, so it falls under the types and the elements. So you can actually get an element as I think it's a prop, I can't remember, I think it's a field, and that can have a type associated with it. So it can either be a primitive type or actually a more qualified type, like a string, well, that's a bad example, but like an object type class sort of backs it. And you can inspect it and grab it out. So I mentioned before, I'm going to focus a lot on JavaPoet. The guys at Square Open Source actually wrote this library, and it's a sort of concise API for generating class files. And there's another thing called Java Writer, I think, where it's basically you have to construct everything that would have been in a Java class file yourself and then sort of spit it out. And it's kind of ugly and not really worth bothering looking into. So this is a nice little wrapper for it. Actually, from the Google Auto library, there's something called Auto Service. And this, you don't really see it being used too much, but it's actually kind of handy, because it generates the meta-INF annotation processor file, actually, and it helps reduce a bunch of the boilerplate. All good? And the cool thing is it's actually an annotation processor itself. A bit of an alternative to JavaPoet is actually using Apache velocity templates. And yeah, I'm probably just going to point that out just to point out that it exists, but I prefer using JavaPoet. So this is actually a bit more of a primer as part of it. If anyone's actually using Kotlin to write their code, Square Open Source have actually got something called Kotlin Poet if you want to use that. But because Java and Kotlin are interoperable, you can sort of mix them together anyway. But that's the GitHub for the JavaPoet library. You can sort of grab it down. They have a bunch of useful documentation. It's being pretty actively maintained, and it's actually really cool. So what JavaPoet employs is this sort of a builder pattern around Java class files and sort of the constructs for it. So they have a bunch of specs, as they call it, and spec builders. And they've got something called types. So it's a type spec, so you can generate classes, interface, enums, typically things that you'd normally develop anyway with OO programming. It's got a field spec, so you can actually generate fields within your classes, kind of handy. Method and parameter specs, again, kind of handy when you're writing OO code. And then a code spec, which is probably where most of your development happens. One thing that is kind of worth noting is that these specs aren't actually supporting any destructive operations. And this caught me out for a little while because they actually provide a lot of utility, but you can't, remove, modify, or do anything like that to an other type spec. So you have to, you have to sort of build everything up yourself as part of it. If you want to define a class, the type spec actually has a bunch of static methods against it. And all you need to do is you need to pass it a class name, and it will generate a type spec for you. Obviously, because Java is OO, you can add superclasses, super interfaces, fields, methods, type variables. And during the compilation, it will actually do a bunch of validations. So if you actually add 2 superclasses, which isn't a thing in Java, unfortunately, it will actually complain and sort of explode as part of compilation anyway. So it's kind of handy. Usually when you have objects and classes and types, you have fields associated with them, so you'd use a field spec builder. So you can actually pass it a type, give it a name, and then you have a bunch of modifiers. So it's actually got a varargs list of modifiers for it, so you can do private finals, do whatever. Then you have an initializer if you need to, and then you can actually shove in a code block, so it's kind of handy for constructors, and if you don't want to use constructors for everything, for example. And then you can sort of build on top of that, and that's probably the most common. For methods, you have a method spec. So you keep adding these to a type spec, obviously, and you just give it a method name. You add annotations on top of it. You can also do that to the sort of the field specs. You have modifiers, return types. For parameters, you use a parameter spec, and then you build it, and then you can add your code. So I actually borrowed this from a library, just to sort of demonstrate it. Freez is sort of one of the constructs which is part of my stasis library. So the point of stasis was that you can preserve objects by inspecting fields and grabbing its values, then sort of reattaching it. So that's just the method name for it. Yeah, so up the top. Yeah. So this is probably going to be in my learnings, but use constants a lot. They're kind of handy because you need to sometimes refer to code, refer to generated fields and things like that from other classes and other builders and other things like that anyway. So that's a bit of a pro tip. And probably the good bit, oh, actually not the good bit just yet, is that you can actually easily override a method. So if you combine some of the previous things, which are sort of fundamental types, if you get like a method from like your inspected code, you can actually override it really easily and provide that implementation. This is probably the really, really nice little bit. So if you have generics, and I'd sort of just assume there would be generics in your classes anyway, this version of overriding actually automatically resolves generic types. So I said generics are tricky. You can do it manually, or you can just use JavaPoet's method, and it sort of helps you out. Oh, so if you had like 3 classes that sort of extend each other and you're sort of passing on the generic types as part of that, that will help resolve it. But usually you'd use it for your own code anyway. Yeah, but what happens is whenever you're inspecting a sort of element, it doesn't really have the fully resolved generic information. It's actually giving you the generic lower and upper bounds, and that's it. So what those methods do is actually kind of cool. They sort of search up the actual hierarchy for your class, and then based on the types that are of the declared class, I mean not the declared class, the class that you're sort of overriding, the class's method that you're overriding and its maximum superclass, it resolves those generic type bounds for you.
Yeah, so I guess
Yeah, that's right. And actually accessing classes is one of the weird things with the framework. Oh, whoops. So this is sort of where all the good stuff is. So obviously you've got to write code from all this. You can use these code block builders as part of it. You just say new builder. You can use the control flow statements. So this is actually a very generic statement. A control flow is anything that's really a Java block, I suppose. So you can do for loops, while loops, if-else statements, whatever you really need, that sort of thing. You can add statements on top of it. This is actually a very simplistic example, and I don't want to complicate things too much as part of it. And it's sort of got this builder pattern where you can construct your code sort of nested. Probably one thing that you'll notice is that I've got no semicolons at the end of my code. So whenever you say add statement, you don't need to add semicolons. It's actually very handy. It means that you're sort of doing something like Kotlin, where you don't have to add it in. It just adds it in for you. If you wanted to add semicolons in or do things manually, there's actually a statement called add, where you just add in raw code. And probably one of the weird things is that you're probably having a look at this and going, oh, is that string.format? There are these bunch of weird placeholders that are in there. And that's what this slide is about. So as part of JavaPoet, it helps sort of deal with all of the weird typing and the type system, and it helps you substitute and plug things in really nicely. So it's got things for literals, it's got things for types, raw strings, and then names. But I find most of the time you're probably dealing with the first three and you're not dealing with $n for names. But if anyone wants to really sort of look into them, there's actually the documentation for them. And this is how you actually refer to types. So you can actually use this JavaPoet class called typename. You actually pass in a type mirror, which you get from your elements, and your types, which are your JavaX, and like your raw annotate. Your JavaX class is provided by Java itself, not Aniruddh. Excuse me, not JavaPoet. So you can pass in type mirrors. You can actually pass in strings. As long as you resolve it somehow, you can plug it in. And this is how you deal with generics. So you just pass in the generic class, and then you pass in your generic arguments and your types. And this is how you dump out a file. So it's actually all part of the framework. I like to add this file comment as a bit of a way back to my .NET days, where Visual Studio would actually give you those templated files out, and it would say this code was generated by a tool. The tool, not an actual person, hopefully. And also I find it very useful as a developer developing an annotation processing framework to have this little line down the bottom. It's just an if-else statement, and you can actually dump that out to any print stream or output source. So that just prints it out to the console. So you can actually inspect what's being generated without actually directly going to the folder where it's generated to. Rightio. So now we're going to get more into some sort of code and some steps around actually developing things. So, oh, question? Yeah. Yeah, so you can do that. You can actually add an existing code block to another code block if you wanted to. It's just up to the code that you write to write the code. So the framework is sort of there to sort of give you the tools, and it's up to you to actually make use of it, I suppose. So whenever you start writing an annotation processing library or whatever, there's sort of a bunch of steps that you want to do. The first thing that you want to do is, I'm probably going to focus on this from a sort of Gradle perspective, but it's probably going to be similar if you did it for Maven. You want to actually set up a bunch of modules. So a common pattern that you see with a lot of annotation processing libraries is they have a sort of library class, which is standalone, and all it does is define the annotations and types and interfaces and the sort of boilerplate that you want to expose to your users. Then you want to have a compiler module, and this is actually where you're going to define something that actually does the annotation processing. And if you want, you can actually add other modules. So as part of Stasis, I've actually defined these first two modules, and then an Android-specific one. So it means you have the flexibility to do something which is Android-specific, or it's actually Java in general anyway. As part of your library and your library module, you want to define your annotations and all your framework classes, of course. And when you start writing your compiler or your annotation processor, you want to sort of boilerplate out a bunch of things, which I'll show you guys. And then there's a sort of processing loop phase, and this is where the sort of magic of annotation processing happens. So, as promised, I'm going to sort of give this a shot. And I'll see if I can sort of switch to present mode. I think the top is actually being chopped off a little bit. I'm just going to mirror my screen, I reckon. That's better. Yeah. My Mac is actually getting quite old. So I'll probably start off with the project configuration. This might be a little bit hard to see, unfortunately, because I don't know if you can presenter mode on the actual project structure. But as part of this, I've got 3 modules set up. So we've got the library class, your library module. I've set up a bunch of annotations as part of it. So you have something called preservation mapping, preservation strategy, and a bunch of sort of preserve annotations. And this is what you annotate your fields against for preservation. I'm not going to go into how it actually works. And then there's a sort of couple boilerplate reusable things that are sort of non-specific. Just sort of point you to the Android one, so if you want to add that on, this is its own separate module. And there's some more Android-specific code, so a bunch of nice little defaults as part of the library, and some other classes as part of that. And I've just got a demo one because I was doing this mainly for Android. I've got an app package. This is just to sort of build everything out and sort of try everything out and make sure everything's compiling properly as part of the process. And yeah, switch back to presenter mode. And we want to go to Stasis processor. So I'll sort of go through the code. I've actually written a bunch of annotations, which you can't, well, to-dos, which you can't really see too well, unfortunately. But this is your sort of class that you'd probably define. You can name it whatever you want. A sort of good convention for this is to name it library name and then processor, or library name and compiler, depending on your flavor, what you like. One thing as part of this, as I said before, is I'm using Google Auto Service. And this little annotation over there actually indicates to Google Auto Service that it should use this class as the actual annotation processor in that marker file. Here's a bunch of boilerplate. You can sort of see a lot that there is this test flag. It's sort of used throughout the annotation processor, but I've cut it out. You can have class names, and the way I'm just grabbing that is this module actually refers to the library, and then you can just say class name or get, and then pass it a class, and that's just nice to have around if you need to use it. This is a bunch of the initialization boilerplate, so you get this sort of processing environment, which is meant to be like a very abstract representation of your execution unit for an annotation processor, and it gives you those utility methods and classes that we've probably seen before as part of that. And you actually should use this specific method. So as part of the abstract processor class, there is a get supported annotation type. So what this does is it registers that your annotation processor will start consuming certain annotations. If you miss that out, it's kind of not nice, and then your annotation processor doesn't work. And this is the sort of backwards compatible way, especially with Java 6, and if you want to make this available for Android, this is a sort of a way to just indicate for the annotation processor framework that these are the annotations used. Alternatively, if you don't really care about Java 6 and below, you can actually use an annotation to declare the supported annotations, which is kind of handy, but again, you lose your back. And then there is this nice little method called process. So this is the sort of processing loop. And sort of if you look back at the compilation overview, it's going to keep hitting this method as part of the compilation, and it basically gives it what's called a rounded environment, which has all your annotations, and it sort of searches for everything. And this is where sort of all your magic happens. So one of the processing quirks is that annotation processing is multi-pass. So I think, as I said before, it keeps processing until no class files are generated anymore. So you can actually tell when the processing is actually over, and this is a nice little shortcut for that. I'm just going to see if I can get it again. And one thing is also as part of that is sometimes you would actually have no classes that are returned that have the annotation. So this is another early age that sort of says, okay, I'm done with processing. I don't need to keep iterating. And sometimes you get some weird side effects if you don't do these kind of things, like double generating class files, which is a little bit weird. As part of the question? Yeah. So, I can't exactly remember what this says. Damn it. Yes, it does. So I think if you return true, it means that it should not continue processing with that annotation processor. And if you return false, it means that it could potentially come back. So there's a slight difference between the two. Yeah, so you can have an annotation processor that generates classes that are annotated with the same annotations, and then that will be dealt with in the second pass, for example. So that's actually a really good question, and thanks for pointing that out. One of the approaches I used as part of this library was a bit of pre-processing, and this is sort of where it sort of does a bunch of mapping and extraction, and as part of that, it sort of gets around the environment. It looks for this preservation mapping class. It does a bunch of pre-processing, and you can actually look at the code. It's all on GitHub anyway. And basically, it creates a sort of construct where it tries to find out where exactly this specific annotation is used, if I can optimize the code, make sure that it's not doing multiple passes, not generating multiple classes for the same thing, that kind of stuff. And also, it uses one of the annotations as a sort of metadata indicator. So if you want to map, if you want to define a mapping or preservation strategy, which is part of it, you can say that, strings are stored this way using this class, and it does that mapping, and you can override it. Bunch of other stuff. I'm probably going to skip over this, because you probably want to see how it works. Stasis processor. The next bit is the next part of the processing loop. So after the pre-processing is done, it generates a list of class files and what to generate as part of it. And basically, out of the processing configuration, it gives you all your targets and everything. A bit of an interesting thing is if you have classes that are nested in classes, this is a little bit of code that helps you sort of sanitize it. So use the $ symbol to say that, you've got a contract, and the contract has a view, for example, that we have in Android, or as part of an MVP framework. You have something that's named stasis, preservation mapping, contract $view, and that helps disambiguate things. And you can sort of generate that class name as part of it. One other thing is, where is it? Class name, get, reserve member, class. I've actually lost myself. Oh wait, there's the debug information. Sort of going back to JavaPoet, this is how you sort of generate a class name, and you can sort of use this sort of builder pattern, which I'll talk about in a second, to apply each and every bit of the actual source code. So this is actually relatively simple in terms of what it outputs, and I'm not going to bother going through it actually. and then you obviously output each class file. So you've probably seen a bunch of this stuff already as part of the JavaPoet primer. I'm actually going to swap out of presenter mode, and if everything works okay, and I rebuild the project, and you have output for the project, which I think should work, and it compiled. Great. So I might just poke at the source code a little bit. Ah. Command 1. Oh, sweet. I didn't know that. Thanks, Con. So this is a construct from it. This is the class. So these are the actual annotations that are being picked up by the annotation processor. So these are actually some Android UI things. That's what the annotation processor picks up. Probably a good thing to show is actually how you use the damn thing, Ani. In Gradle, to get that out of the way, I'm using an Android project, so I'm using the annotation processor directive, but you can add your library as a dependency. If you're referring to it from an external source like Maven Central, JSON, or that sort of a thing, you just put in the dependency and then the version name. Get that out of the way. That's the Android version of the dependency, and this is the sort of marker that says this is the annotation processing library that is being used, and it adds everything to the class path and makes it available for your code. And yeah, so this is actually part of the Android one. I think I talked about APT as part of the Dagger one, so if you wanted to use APT, there's a Nienbedankt APT plugin, I believe. But it's not supported anymore because it was sort of more targeted towards Android anyway, Android users anyway.
Do you know much about, like I know with Maven you can specify something with the provider's scope and it's still...
Yeah, I can't remember with Maven because Android developer use Gradle a lot, but I think there is something similar. I think I linked the Maven document as part of that, which would have done it for you if you were using Maven. And preservation strategy main. I can't make this any smaller, but this is basically the annotation processor output code. So if it was something more complex, there would be potentially more files as part of the output as part of this, but all of this is actually being generated and spat out by the code that builds the code for the annotation processor. So just does a bunch of mapping. All of these values correspond to a sort of field in a class, which is what it's meant to do. So for example, that is all generated. Because it's generated as an annotation processor, if you ran ProGuard on top of this, you don't have to deal with reflection issues where you can't find the values. It's referring to the same property. But one thing to probably point out is that these are package scoped, so they can actually be accessed by the outputted class. Cool. Anyone have any questions? Yep. Oh, sorry. No. So this auto service annotation is not used as part of JavaPoet. It's used to generate the marker file for Java compiler. And that sort of indicates that this library or this asset or this jar is an annotation processor. So it gets sort of hidden away because it's at the top of the class and you only do it once per annotation processor, but it's not related to JavaPoet. But yeah, because you've got Google Auto included, it actually isn't part of the annotation processor. Start again. Because you've got auto service included, it runs its own pass as an annotation processor and spits it out. So yeah, does that answer your question? Cool. Probably all the JavaPoet classes are actually hidden away as part of what I sort of call my builders as part of it. So does anyone want to actually have a look at the more JavaPoet stuff? No? Okay. are the JavaPoet things here.
So generating the class from a type spec.
And modifiers, that sort of thing. Oh. Hey Jason. Hi again. Yeah, so let me see if I can find this. So, pop back into presentation mode real quick. So, if I go to main activity, and as part of my builder pattern, which I'll probably sort of talk about, I have a method called apply fields, for example. This basically applies all the fields to the class, so you have a nice more testable way of checking what's actually being outputted. So as part of this, you have a type name which is derived from the actual field. So if I pop over to the main activity, we'll have things like the text view, for example, that gets extracted from it. It generates a field name for it as part of this method, which just generates a string. Then the referring class, so the type spec, which is declared outside of this as part of the processing loop, is passed in. You just call this add field method. You pass in a field spec builder, give it the preservation strategy, which is part of it, have your field names, and I've actually done the modifier, the initializer for it. So going back to this, if it was for the button with the custom preservation strategy, it would basically generate this whole field. For something like a method, if you go sort of apply methods, it sort of keeps everything grouped together again. You set up a bunch of code blocks. I'm actually building 2 methods as part of the same for loop, so it's not repeating the same thing. So you have a field that you're annotating. You have a method for the freeze method and an unfreeze method, which is part of the construct, which is part of my framework. If the memory is nullable, it does a generation for that, and this is the code for it. And you're sort of seeing the sort of references and things that are part of JavaPoet. You have a couple of very simple control flows. You have add statements which add code to the control flows, and then it sort of just ends it. And then it adds the method with the code and all the fields and everything, and the parameters, and the annotations, and everything else on top of that. And then it builds it against the type spec. And that's how you get the freeze method. Obviously, you can make this as complex or as simple as you want to. It doesn't have to be too crazy. It can be things that you commonly boilerplate out as part of your code or repeat. So this is something that I would have done by hand anyway if I wanted to do it as part of experimentation. But now it's an annotation process, so I don't have to repeat myself.
How do you find IDE integration? Like, so say you have stack trace in your IDE, you click on the generated class to the link, to the generator source.
Yeah. So if you're using APT, you actually have to do a little thing where you sort of point it and say use the generated classes, because it dumps it into an APT folder. If you're using the annotation processor directive as part of Gradle, it automatically does it for you. So command 1, it sort of gets spat out as part of this folder, and you can refer to it in your code. So as soon as it's compiled, it's accessible. And here is the actual class reference. You can click on it. IDE the IntelliJ support is all there. So, yeah. And you can use it as normal. If you've got any fields or anything that you want to view, you can review it. Anything else? Okay, so yeah, so I'll probably get into that in a couple slides. Okay, so now we've seen Some code. I think I mentioned the sort of pre-processing patterns. You can make your code as sloppy or as nice as you want. It's due compilation time, so if you're building jars, it sort of doesn't matter as much, but remember, it's going to affect your build times. Class builder pattern, it's up to you how you structure this, but generally what I like to do is have a class builder per outputted class. You have methods to apply the fields and sort of build on top of the outputted classes. One of the sort of interesting things that Dagger doesn't do really well is the sort of failure handling approach. It just sort of goes, oh, a bunch of things went wrong and you've got to dig through the logs. So you can sort of employ a couple of approaches, which is to fail on the first error, which I don't recommend. But what I would like to do is actually log every single error as much as possible and try and direct people to, with instructions on how to fix it. And also error detail is sort of important. You want to make sure that people can find out how to fix it relatively quickly. So with Dagger, it goes, okay, compilation, annotation processing failed. Now all your references to what would have been generated class don't exist, then you've got this mess going on. So I might actually show this since someone asked. You can actually, how about a presenter mode for this? You can actually debug in a couple ways. You can sort of be sloppy and do system out print line at each point of the code, which I sometimes do because it's useful seeing what gets dumped out of it. But for example, I'm just going to dump a little breakpoint somewhere and go into the terminal. This is the Gradle version of it. You can actually start Gradle with debug mode. Gradle W, and I'm just going to say build, and I think it's --debug. Is that right, Con? Gradle is debug? Oh, wait. I might cheat a little bit and actually look at my presentation, because I haven't had to debug things in a while. Bloody hell. You should have forgotten. Right here. That's the one. So, what this does is it fires up Gradle, it starts the daemon, it starts Gradle running. You can do this with Maven also, so I've got instructions and links to everything. And if you go into your run configurations as part of IntelliJ, fire up a remote, and if you've got all your ports set up as default, go apply. Please, please, please work. Why isn't this working? Why is it still starting the daemon? Okay. Sometimes it's actually faster just to use system out print line, but slightly cheating. For some reason, my computer doesn't actually want to run Gradle. But if it was running Gradle, and if you'd run a build, what would happen is it would sort of pause, because you've got the debug flag enabled. And then as soon as it hits your annotation processor code, your IDE would hit the breakpoint, and you can actually debug and step through normally, as if you're actually debugging your standard code. Still doesn't want to start. Okay. Yeah. Yeah. So if you, that's basically what it does. So I can't remember the default port. I think it's 5000 or something like that. So whatever your build tool has, it would probably fire up a port. And you can actually attach your attach your IDE's debugger to it, so you can look into it. Yeah. Yeah. Thank you, Con. Yeah, that's right. If you're using Maven, that's the link for it. But one thing which I wanted to point out is that instead of using system.out.println, this is actually part of the processing environment. It gives you a messenger, and you can actually print messages. So if you fail compilation, you can log an error. If you fail, or if you have a certain warning that you'd like to display to the user, you can sort of log that information, and that's more apparent as part of your actual your compilation output. So some of the gotchas, I think you probably saw this before, was those multiple early exits. There's multiple conditions that you can hit for it. Because of incremental compilation is part of some of your build tools, you might not actually always get the latest version of your annotation process and generated code. So all you need to do to get around that is hit rebuild on your project. When you're defining your annotation, you sort of need to make a decision. So there's something called your retention policy on your annotation. So you want to choose between source or class. And you'd use source if you only want to expose, for example, your generated code as part of the library or the module that you're using. But if you want it to be continually consumed outside of the library and you want to expose it even further for your annotations even further, then you'd assign it to the class level, and then you can have projects that depend on projects that use the annotation processor and generate it and output it that way. With your project choices, I'd recommend using a sort of pure Java approach. If you want to include any of the Android source files as part of your annotation processor, it's not worth it. So the way that you get around it is actually by referring to the classes and all the things by their actual package and class names. So that's a bit of a pain. Sort of as part of the learnings, here's some useful snippets that I use a lot. So accessing class values, quite a lot of times you'd say, I want to use this class as part of my annotations, and you actually can't directly access classes during the annotation processing phase. Anyone want to take a guess at why? Bingo. That's one of them. There's actually a couple reasons. So obviously it hasn't been compiled yet. Your loading info is not potentially available. And your class might not be loadable in the first place because it hasn't been compiled yet. And you can sort of see that looking back at the compilation overview. But luckily, you've actually still got a reference to them, and that's where the type mirror comes in. So this is a little bit sketchy sometimes, and it feels really, really weird. When you want to access an annotation's value, if you look for this certain exception, you get a type mirror exception, and this actually gives you a type mirror, which you can convert into a type, and you can refer to the actual class that way. So this is a little bit of cheating that happens as part of it, and it's kind of funny and it feels icky. Depending on if your value or field in your annotation is mandatory or not, you can actually fail. But that null pointer exception may or may not be reachable. Most of the time, if you've got a non-null value, you can actually enforce that it's there and get the type value and have a failure as part of your compilation to indicate that this field's mandatory. But sometimes there's code that's not reachable. If you have an array or list of classes, there's a type mirrors exception, so plural, and that just gives you a list. So you can convert that to whatever you need and do it. This is actually what JavaPoet does when you say method spec overriding. This probably won't make sense just yet, but this is how it sort of looks up the class hierarchy, goes all the way up, and resolves all the generic types. A lot of learning curve with that stuff. I actually wrote my own version of that and didn't know it existed. I'm like, oh yeah, this is great. I'm going to publish to everyone. Everyone is going to be so happy that I've got this new utility and it's already there. Shit. Type erasure is actually kind of fun. So this is more into the generics is tricky bit. Sometimes you want to check if classes are assignable and you want to ignore the erasure component for it. So type utils, which is aka types, you can actually just say erasure and it will get rid of the erasure information, and then you can do the comparison. It's kind of nice. This one I tend to use a lot because I'm looking at interfaces and I'm expecting interfaces to sort of be nested and have a sort of hierarchy as part of it. This little snippet allows you to get basically all your fields or members or whatever up to the object level. So if you've got your object, you've got interface A, which is extended by interface B. It will resolve all the methods by looking everything up and then filtering it. And if you want, you can optionally ignore everything that comes from object. So hash code equals anything default that's there. Sort of wrapping up, I've had a lot of learnings mucking around with annotation processing. It gets pretty fun and you get a little bit hardcore when you get into it. But when you start writing your annotation processor, you probably will write a God class which has every single thing and it's extremely long. Feel free to do that. Start breaking your code down after that. It will sort of feel nicer and then you can sort of start testing things further. That's in some libraries which I've not really talked about this time around about it. Explore the utilities, they're very handy, and the Docker. Use constants for class definitions because if you're referring from multiple classes, it comes in very handy. Stick to the fundamental types. So I actually made a couple mistakes and you can probably see that in my commit history on GitHub. Log all the errors, make sure it's at the right detail because there's nothing like having a giant stack trace which is useless. Learn by doing and basically keep reading the Docker because, again, years worth of learnings later, you finally figure it out and realize that it's been there all along, you waste a bit of effort, you have a little bit of fun. Sometimes it's worth it, sometimes it's not. As a bit of a reference, Hans Dorfman actually has a sort of tutorial on how to write annotation processors. It's quite good. If you want to look at my presentation instead, that's even better, I hope. Some example libraries that I used as a reference was actually Dagger and Butterknife, but more primarily Butterknife. And that's it. So we probably had a lot of questions before, but does anyone want to ask anything else?